welcome everyone to this third lecture of Professor Brandom's Pufendorf lectures. This is the final one. If you're joining us now, it's late in the series, but you're very welcome anyway. If you're joining remotely and you want to ask a question during the Q&A, please write in the chat that you want to ask a question, and we'll try to accommodate that. In the chat, you can also find the handout for today's lecture. And please note that the lecture and the questions will be recorded. So if you don't want to be recorded, please don't ask questions. Without further ado, help me welcome Professor Brandom.
Thank you very much. The main aim of my first two lectures was to put on the table the concept of reason relations, of implication and incompatibility, and to show how that topic appears from the points of view afforded by different ways of talking about it. From the point of view of bilateral pragmatic theories of the use of declarative sentences to make claims and defend and challenge them by giving reasons for and against them, reason relations show up as norms, determining which constellations of bilateral doxastic commitments to accept or reject a speaker can be jointly entitled to. From the vantage point of truthmaker representational semantic theories of the meaning or content of declarative sentences, reason relations show up as alethic constraints on the compossibility of truth-making states for premises and falsity-making states for conclusions. And from the vantage point of sequent calculi, codifying meta-inferential rules for computing new reason relations from old ones, reason relations show up both as what is elaborated from the reason relations of a base vocabulary and made explicit by conditional and negating locutions in a logical extension of that base vocabulary. Throughout, I've held out the prospect of understanding the claimable conceptual contents expressed by declarative sentences in terms of those reason relations they stand into one another. This aspiration is in service of a top-down explicative strategy. Just as reason relations, I'm specifying from above, triangulating them in terms of the pragmatic, semantic, and logical rational metavocabularies that talk about them. So the reason relations I identify there are to be called on in turn to articulate functional definitions of propositions in terms of the roles those sentential conceptual contents play in implications and incompatibilities relating them. Today, I want to make good on that promise by cashing out the metaphor of roles. Yesterday's theme was logical expressivism. Today's is semantic inferentialism. As with the technical results that were at the center of my previous two lectures, the important thing is to understand just enough of the details to appreciate the meaning or the significance of the construction. In this case, I also think there's an aesthetic dimension. There's a sort of pretty structure I'm going to elaborate, and we can admire it. The previous discussion gives us a place to start. Fine has a robust metaphysical conception of the propositions that stand in reason relations. For him, they're pairs of sets of states that are eligible to serve as truth makers and falsity makers of sentences, which means they have to satisfy his exclusivity condition. Any mereological fusion of exact truth makers with exact falsity makers of the same sentence must be an impossible state. The global isomorphism at the level of reason relations between truth-maker semantics and bilateral pragmatics ensures that there's a corresponding conception of the claimables in terms of which constellations of doxastic commitments to accept and reject those claimables discursive practitioners can be jointly entitled to. Basically, that one cannot be entitled both to assert and deny the same claimable. These are serviceable notions within their own semantic and pragmatic domains. What I want to emphasize is how different these conceptions of propositional content are. Each essentially appeals to substantive conceptions native to its setting, but alien to the other setting. In the one case, metaphysical mereological fusion and modal possibility or impossibility of states, and in the other case, deontic normative concomitance of doxastic commitments to accept or reject and preclusion of entitlement to those commitments. These two accounts of reason relations, and so of propositional conceptual content, are shot through with substantive, semantic, and pragmatic concepts that they use to explain their parochial concepts of consequence and incompatibility. What we're after now is something more abstract, something these conceptions have in common, just in virtue of the propositions each account in its own way understands as being related to one another by reason relations that are intelligible as isomorphic across the two settings. One way to fill in that conception is to define a conception of rational proposition or conceptual propositional content in terms of what I earlier called vocabularies. That is, abstract relational structures consisting of a lexicon and a set of relations defined on the lexicon. The domain is a set of sentences or bearers, and taking our cue from the multi-sequent calculus idiom for specifying reason relations, we can represent the reason relations in a vocabulary by a set, I'll call it I, of pairs of sets of lexical items, where for the pair of sentences x, y to be in I means the implication with premises x and conclusions y is a good one, according to that vocabulary. Vocabularies specify reason relations in the sense in which the global isomorphism shows them to be common to what shows up in deontic normative guise, in a bilateral pragmatics, and in a lethic modal guise in truth-maker semantics. This isomorphism at the level of reason relations is the basis of what in the first lecture I called bimodal conceptual realism about reason relations. The view that at least when all goes well, the very same reason relations that normatively govern practices of making claims and rationally challenging and defending them can be understood as modally articulating the world that is thereby talked about. And we've already seen how to do logic with vocabularies in this spare technical sense. For the structural principles and connective definitions of sequent calculus metavocabularies operate on a base vocabulary in this sense to compute both the lexicon and the reason relations of a supervocabulary of it. Its lexicon is a superset of the base lexicon, produced by adding logical compounds of base sentences, and its reason relations are conservatively elaborated by the sequent rules from the reason relations of the base, so forming a superset of those reason relations. The question I'm addressing today is how to define a formally tractable and philosophically useful concept of the propositional conceptual content that appeals only to this minimal foundation of the reason relations of arbitrary, material, that is, non-logical reason relations. The construction I'll present is implication space semantics. It was originally adopted by role contributor Daniel Scott Kaplan at Pitt from Jean-Yves Girard's phase space semantics for linear logic, and it was developed further by Ulf Lobel for our book. Implication space models are just another version of vocabularies. An implication space is formed from a lexicon of sentences as the set of all the candidate implications in the lexicon. If the lexicon is the set of sentences L, this is the set of all pairs of sets of sentences of L. Each element of the implication space generated by a lexicon is thought of as the pair of the premise set and the conclusion set of a candidate implication. An implication space frame is then an implication space together with a distinguished subset I of it, interpreted as the subset of good implications, the ones that really hold, according to that model. Clearly, this implication space redescription just lightly repackages the same information that's already available when it's shaped as or put in the form of vocabularies. But implication spaces whose points are candidate implications, gives us a good way to visualize sets of reason relations which show up just as subspaces of them. We can get a philosophical hint as to which features of these structures it'll be most revealing to associate with sentences as articulating their conceptual contents by listening again to my hero, Wilfrid Sellars. We've already appropriated 2 lessons from him. In my first lecture, I invoked his reading of Kant to motivate an inferentialist top-down order of explanation. With the quotation, this is from Sellars, Kant was on the right track when he insisted that just as concepts are essentially, and not accidentally, items which can occur in judgments, so judgments, and therefore indirectly concepts, are essentially, and not accidentally, items which can occur in reasonings or arguments. End of his quote. Adapting this language to that I've been employing, Sellars' criterion of demarcation for specifically conceptual contentfulness is situation in what he calls a space of implications, which normatively govern what he calls language-language moves or inferences. And I followed him here in these methodological commitments. Sellars makes a further claim about the implications he understands as articulating conceptual content. They have to be subjunctively robust. I think this point is maybe best appreciated from the side of pragmatics, by considering what one must be able to do in order to count as grasping some non-logical concept, such as lion. The first point is that one must be able in practice to distinguish candidate implications and incompatibilities involving it that are materially good, and distinguish those from the ones that are not, however complete and fallible that ability might be. That is, one must be disposed, for instance, to treat the fact that a lion is very hungry as providing good reason to think that it'll attack a nearby gazelle rather than a large rock, and as a reason against expecting it to sleep lazily in the sun or flee for its life. One might have no dispositions corresponding to many such good implications and incompatibilities, and one might be mistaken about some of them. But if one makes no such discrimination, then one is not deploying a concept. You don't know what lion means unless you can make some discriminations like that. One's grasp of the concept essentially involves making at least some rough and ready practical distinction between the materially good and bad implications and incompatibilities that it's involved in as a premise and a conclusion. But more is required. One must also practically associate with each of the implications a range of subjunctive robustness. That is, one must have some sense of what differences would make a difference to the goodness of the implication. This means realizing that the lion's hunger would no longer provide a reason for expecting it to chase the gazelle if the lion or the gazelle had been struck by lightning, squashed flat by an elephant, or shot by a hunter, but that the goodness of the implication would not be affected by the position of a beetle on the branch of a distant tree or the day of a week being a Tuesday rather than a Wednesday. Just as one must be able practically to sort candidate implications into good ones and bad ones, one must have some sense of which changes to premises or conclusions would make or keep it a good implication. The implications that articulate the conceptual content of defeasible non-logical claims, such as the lion will chase the gazelle, are not what Pierre Abelard called consequences hic et nunc, here and now, which have no consequences at all for what would follow if things were even slightly different, if the premises were changed in any way. Rather, they're good implications as instances of a pattern, and to understand them, one must have some grasp of that pattern of other neighboring implications that would also be good if this one were. The lesson that matters for our project is that there's an essentially modal element to reason relations as such. The semantic significance of any one implication depends on its neighbors. on the goodness of candidate implications with slightly variant premise sets. This thought motivates the first of three ideas that determine the steps needed to build an implication-based semantics. That idea is to pursue a top-down order of explication in which semantically interpreting implications in terms of other implications comes before semantically interpreting sentences in terms of the implications they're involved in. The first semantic interpretant of a candidate implication is just its range of subjunctive robustness. This RSR, range of subjunctive robustness, is a matter of which additions of premises or conclusions to a candidate implication yield good ones. The RSR of a candidate implication consists of all of its good implicational completions. The pair of additional premises whose addition would make it good, the pairs of additional premises whose addition would make it good if it's not good, and keep it good if it is good. The range of subjunctive robustness determines the intentional element of the implicational role of a candidate implication, as its value as a good implication or not, what we could call its goodness value, is the extensional component. So these are parallel to truth conditions, the intentional element, and truth values, the extensional element. We have the goodness or badness of an implication as its extensional interpretation or value, and its range of subjunctive robustness as the intentional one corresponding at the level of reason relations to truth conditions at the level of sentences. When, at the third stage in our construction, we finally assign propositional conceptual contents to sentences, that's where I'm going, haven't gotten there yet, those contents need to be identified and individuated finely enough to respect and determine not only the extensional issue of which implications are materially good or bad, according to that implication space frame, but also the intentional dimension of their complex ranges of subjunctive robustness. Now, in classical topologically closed, specifically monotonic settings, the ranges of subjunctive robustness of each implication have the same form. If at a certain point adding further premises or conclusions to a candidate implication yields a materially good one, then all the other implications accessible from it by adding even more premises and conclusions are also good. But in non-monotonic settings, where adding premises or conclusions can turn a good implication into a bad one, ranges of subjunctive robustness of implications are much more complicated. In both settings, there's important information in the facts about what additional premises and conclusions it would take to make good implications out of a candidate implication that is not, as it stands, good. So I'm thinking of each of these candidate implications as surrounded by a cloud of good implications that you can get to from it by adding premises and conclusions. And those ones that you add to get to good ones, that's the range of subjunctive robustness. In both settings, the question is, what does it take to make good implications out of a candidate that is not good? We can adequately represent that complexity by associating each implication with each implication as its semantic interpretant, its range of subjunctive robustness. In fact, we do this by taking all the other candidate implications that when dual unioned, with the implication being interpreted as union the premises and union the conclusion, we take all the pairs like that, that when you dual union them with our candidate one, give you a good one. The second big idea shaping implication space semantics is that we want to group together lexically different expressions that play the same semantic role. If two candidate implications have the same range of subjunctive robustness, then they play the same implicational role and are accordingly semantically equivalent. So, looking forward, if substituting one sentence for another never changes the range of subjunctive robustness of any implication they're involved in, then we can treat them as semantically equivalent sentences. The implicational role of an implication or set of implications can be represented by an equivalence class of implications that all have the same range of subjunctive robustness. So we're just grouping these together accordingly as they share ranges of subjunctive robustness. These are still implicational roles of implications. We're not interpreting sentences yet. That's the third stage. Implicational roles are very special equivalence classes of implications. Not every set of implications is an implicational role, but every set of implications has an implicational role, namely the equivalence class of all the sets of implications that have the same range of subjunctive robustness as that set. For all sets of implications have ranges of subjunctive robustness, the intersection of the ranges of the individual ranges, and the roles are just sets of all the sets of implications that have that range of subjunctive robustness. These implicational role equivalence classes of implications are the building blocks of implication space semantics. Henceforth, our principal concern is with such implicational roles. We'll assemble the propositional conceptual contents expressed by sentences out of implicational roles, and we'll define and exploit operations for forming new implicational roles from old ones. This shift in conceptions of what's semantically interpreted crucially lifts the semantic discourse to a higher level of abstraction. When we considered Fine's truthmaker semantics in my first lecture, we saw that worldly propositions in his sense, pairs of sets of truth-making and false-making mereological states that meet his exclusivity condition, can stand to one another in reason relations of implication and incompatibility. Treating a universe of propositions in this sense as the lexicon of a vocabulary, we can generate implication space frames from those vocabularies and compute the ranges of subjunctive robustness and so the conceptual roles of truthmaker implications. The abstraction achieved by treating implications as equivalent if they have the same ranges of subjunctive robustness produces a notion of implicational role that applies equally well to the truthmaker setting or the pragmatic setting. And this means that its implications, and eventually the worldly propositions that we can define in implication space terms, can be understood as playing the very same implicational conceptual roles as those played by the sentences of a linguistic vocabulary as used to make claims and give reasons for and against them. That is, implicational roles capture what's common to the truthmaker, alethic modal mereological semantics, and the bilateral deontic normative pragmatics that I talked about in my first lecture. The third stage, then, in articulating implication space semantics is the extension of the concepts of range of subjunctive robustness and implicational role from semantically interpreting candidate implications and sets of them to semantically interpreting sentences. The move from interpreting implications to interpreted sentences is of the essence of the top-down order of semantic explanation that I've been pursuing from the beginning. To implement that strategy, we have to understand sentences semantically in terms of implications, specifically in terms of the equivalence classes of implications that are implicational roles. Here, the key thought is that each sentence in a vocabulary is most naturally associated with two implicational roles: the role of the good implications in which it occurs as a premise, and the role of the good implications in which it occurs as a conclusion. This conception is a descendant of Dummett's way of thinking about propositional contents in terms of the sentence's appropriate circumstances of application and its appropriate consequences of application, which is something I made much of in my earlier book, Making It Explicit. Now, these premissory and conclusory roles are different sets of implications. The good implications in which a sentence A appears as a premise is a different set of good implications from the implications in which the good implications in which A occurs as a conclusion. But we've got to keep track of both of those in order to understand its implicational role. One is determined by the good implications in which it shows up as a premise, and the other in which it shows up as a conclusion. And the implication-based formal apparatus of ranges of subjunctive robustness provides a simple way to represent those roles. The set of good implications in which the sentence A appears as a premise is interdefinable with the range of subjunctive robustness of the implication A empty set, because that range of subjunctive robustness consists of all the things which, when you join them with that, give you a good implication. And those are just good implications in which A appears as a premise, and correspondingly with the conclusory role. The role script R of A empty set is the set of all the implications that are intersubstitutable, not salva veritate, but salva consequentiae, preserving the goodness of implications, with A as a premise. And similarly, the role of empty set A, that ordered pair of sets of sentences, is the set of all the implications that are intersubstitutable, salva consequentiae, with A as a conclusion. But wait a minute, what does it mean for an implication to be intersubstitutable with a sentence? This is a fussy point, but let me make it. Associating each sentence in the lexicon with native sets of implications is the trick that makes possible a top-down order of semantic articulation, semantically identifying sentences with sets of implications, in our case with pairs of sets of implications, the premissory role and the conclusory role. What intuitive sense can we make of the semantic equivalence of sentences with pairs of sets of implications, which are the ranges of subjunctive robustness of these core implications? The thing to focus on is the relations between implications that play the same implicational role in that they have the same range of subjunctive robustness. Suppose that the pair of gamma and delta, both of which are sets of sentences, is a candidate implication that plays the same implicational role as, that is, has the same range of subjunctive robustness as, the premissory seed that's just the pair of the singleton A and the empty set. Then any candidate implication XY, again, those are sets of sentences, is in the range of subjunctive robustness of gamma delta, just in case it's in the range of subjunctive robustness of the pair singleton A and the empty set. But that means that adding A as a premise to X yields a good implication, X together with A and Y. Just in case adding gamma to the premise and adding delta to the conclusions to that same context also yields a good implication. Its premises are gamma union X and delta union Y are the conclusions. To get the effect of weakening the implication by adding A to the premises, one must weaken both sides, adding gamma to the premises and delta to the conclusion. In this sense, the candidate implication, gamma delta, is intersubstitutable with A as a premise, salva consequentiae. That is, the candidate implication, gamma delta, means the same as, plays the same role in implications as the sentence A does as a premise. That's the trick for associating a set of implications, or really implicational roles, with the premissory role of the sentence and another set as the conclusory role. This is the explanatory route from the top down, from ranges of subjunctive robustness, and so implicational roles of implications, down to ranges of subjunctive robustness and conceptual roles of sentences, with the complication that sentences correspond to pairs of sets of implications. In this way, we vindicate the distinctive inferentialist conviction that sentences should be understood semantically in terms of their role in implications. Indeed, in terms of their inferential circumstances and consequences of application. And notice that these roles are defined in terms of the distinctive kind of modality that's built into reason relations in the form of ranges of subjunctive robustness. Both the premissory and the conclusory roles of any sentence are classes of implications that are role equivalent in the sense of being intersubstitutable salva consequentiae, which is what we codify in ranges of subjunctive robustness. In this way, every sentence A of the lexicon from which the implication space of a frame derives is associated with two implicational roles, two equivalence classes of implications. A premissory role consisting of all the implications that share a range of subjunctive robustness, with the seed candidate implication that has the singleton A as its premise set and the empty set as its conclusion set, and the conclusory role consisting of all the implications that share a range of subjunctive robustness, with the seed candidate implication that has the empty set as its premise set and the singleton A as its conclusion set. But these are far from all the propositional contents that can be constructed from the implicational roles of a particular implication frame. For we can ask, what constraints are there on the choice from the set of implicational roles of an implication frame of two of them to serve as the premissory and conclusory roles of a propositional content? Is there some condition each must meet, other than just being a conceptual role, in order to function as premissory or conclusory roles of some propositional content? Must the two conceptual roles exhibit some sort of Demetian harmony in order to function as a well-behaved propositional content? Well, what do we expect of a well-behaved propositional content? The idea we've been working with from the beginning is that propositional content should be understood to be what stand to one another in reason relations of implication and incompatibility. Those, we think, can be explained in both bilateral pragmatic and truth-maker semantic metavocabularies. Further, in the light of the logical expressivism I elaborated last time, we might want to add, as a sort of acid test of standing in such reason relations, that propositional contents can occur embedded as the antecedents of conditionals that make explicit those implication relations, and negated conditionals that make explicit incompatibility relations. It turns out that we can satisfy all those criteria of adequacy for propositional contents formed by pairing just arbitrary implicational roles as premissory and conclusory roles of propositional contents. We need put no restrictions at all on the choice of implicational roles to serve as premissory and conclusory roles of a proposition, not even relational ones codifying a notion of harmony between them. The full set of propositional contents definable in an implication frame can safely be taken to be the whole set of all the ordered pairs of implicational roles of that frame. In fact, the cases we care about satisfy the very weak containment condition, which ensures that every sentence implies itself. And it follows from Hloebel's isomorphism that this minimal but still substantive constraint corresponds directly to Fine's exclusivity condition relating truth makers and falsity makers of the same sentence. Okay, we're now in a position to appreciate a remarkable but subtle consequence of considering the conceptual contents determined by all the pairs of implicational roles. That is, that the set of good implications, I, of an implication frame, not only determines the propositional contents expressed by the sentences of the lexicon that generated the space of candidate implications, but also many more propositional contents that are not expressed by any sentences of the lexicon, but whose roles are determined entirely by the reason relations among sentences that are in the lexicon, on which both the vocabulary and the implication space are based. The reason relations among sentences of the lexicon generate a substantial semantic surplus of propositional contents that are determined by those reason relations, but are not expressed by any of the sentences in the lexicon. This hidden semantic territory, opened up to view by the original reason relations among sentences of the lexicon, is a complex landscape. Some of its denizens are massively defective, combining, say, the premissory role of "that's a donkey" with the conclusory role of "the pond is icing over," or "electrons are not composed of quarks." They either fail to imply themselves or underwrite bad implications, which makes such conceptual contents unlikely to be of much epistemic use. But other bits of this semantic shadow matter, other unexpressed propositional contents that are generated by the conceptual contents of the items in the lexicon, are of the utmost importance. It's here, for instance, that the propositional contents of all the logical compounds of the contents expressed by the sentences of the lexicon are to be found. That is, the implicational roles of all the logically complex sentences are determined already by the reason relations among the atomic base sentences, but they aren't expressed by any of the sentences in the atomic base. So there's really useful stuff in this semantic shadow matter as well as defective things. The point I want to emphasize is that arbitrarily constructed propositional contents that are not expressed by sentences of the lexicon are still wholly determined by the reason relations of the implication frame they live in, and only the sentences of the lexicon of that frame appear in their ranges of subjunctive robustness and implicational roles. Every implication frame generates such a shadow realm of expressible but unexpressed propositional contents. Sentences expressing these propositions can be added to the lexicon without changing any of the reason relations of the vocabulary. What makes something a specifically propositional content is that it stands in reason relations to other such contents. Since shadow propositions are not expressed by sentences of the lexicon, they don't occur in any good implications in the set I of the frame they inhabit. But their premissory and conclusory roles consist entirely of sentences of the lexicon, and we can define implications and incompatibilities just in these terms. For we can understand a set of premises gamma as entailing a set of conclusions delta, just in case the empty sequent, empty set premise, empty set conclusion, is in the range of subjunctive robustness of gamma delta. An important meta-semantic criterion of adequacy of an assignment of semantic interpretants in a formal semantics is that there should be a uniform procedure for computing the semantic interpretants of lexically complex sentences from the semantic interpretants of lexically simple ones, so enabling the derivation of the reason relations governing the use of the sentences of the more complex vocabulary from those of the base. This is where atomistic bottom-up orders of semantic explication shine. Being able to account for the meanings of more complex sentences in terms of the meanings of simpler ones is the main strength and principal raison d'etre for this sort of approach. By contrast, the criterion of adequacy that a formal semantics must recursively determine semantic interpretants for complex sentences from those of simpler sentences is potentially much harder to satisfy in the context of a top-down order of explication. The thoroughgoing holism of our approach, intensified by the aspiration to handle even radically open structured reason relations, at least makes much more difficult the kind of recursive determination of the semantic interpretants of more complex sentences from simpler ones, which is the strength of the opposed bottom-up atomistic approaches. Jerry Fodor took it to be impossible, and that impossibility showed the bankruptcy of holistic semantic approaches, including especially inferentialist ones like the ones I'm pursuing. The operators for forming complex sentences from simpler ones that we understand best are logical operators. That's why the standard initial test bench for a formal semantics is its application to specifically logical vocabulary. We know how to use meta-inferential rules couched in a sequent calculus metavocabulary to compute the reason relations of logically extended vocabularies from the reason relations of the base vocabularies to which those logical sentential operators are added. That's what I talked about last time. The question is then, whether there are uniform procedures for deriving the premissory and conclusory roles of logically complex sentences from those of their component sentences, so that those roles determine the right reason relations among logically complex sentences, the very same reason relations that are computed in quite a different way by sequent calculus rules. This is a very definite technical question with clear criteria of adequacy, and I'm happy to be able to report that the answer is yes. We can symbolize the implicational role of A by enclosing A in square brackets. And we can decompose that into the pair of a premissory implicational role and a conclusory implicational role. We'll mark the premissory role with a superscript plus and the conclusory role with a superscript minus. And each of those can be further decomposed into the role of what I called the seed implication. That's just A together with the empty set, or the empty set together with A. That level of analysis isn't going to matter much to us now. We want to look at what natural operations there are on combining the implicational roles we're treating as the semantic interpretants of sentences. Because we keep separate sets of books on the premissory and conclusory implicational roles, one natural operation is to create a sort of converse implicational role by swapping them. The negation rules of our favorite expressivist logic and MMS are just those of the standard classical logic, Genson's LK. It's as if the sequent gamma implies delta together with A is a good sequent, then so is gamma together with not A implies delta. And if gamma together with A implies delta is a good implication, then gamma implies delta and not A is a good one. You can move A back and forth over the turnstile as long as you had a negation to it. We can read the left rule as saying that the role of not A as a premise is the same as the role of A as a conclusion. And the right role is saying that the role of not A as a conclusion is the same as the role of A as a premise, because these horizontal lines are actually, they go in both directions. You'll never turn a good implication into a bad one by moving A across the turnstile and adding a negation to it. So there's one operation on roles that we can understand, and it's going to give us the negation of sentences. But to go further, in addition to this one place operation of swapping premissory and conclusory implicational roles to produce a kind of semantic converse or inverse corresponding to negations, which, remember, codify incompatibilities, we're going to need two place operations that combine different implicational roles to make new ones that are compounds of the original in order to interpret conditionals, conjunctions, and disjunctions. The Boolean algebras that interpret classical logical connectives in topologically closed settings appeal at this point to operations of unioning and intersecting the sets that are assigned to sentences as their semantic interpretants, whether those propositional contents are understood as sets of models or sets of possible worlds or sets of truth conditions or whatever. We can adopt this general idea, saying we need operations of union and intersection, while adapting it to work in the radically open structured settings, and that'll require some adjustments. The example of negation shows that the premissory role of a logical compound can depend on the conclusory role of one of its components and vice versa. So we should think of those operations as applying to a pair, more generally a set of implicational roles, whether premissory or conclusory, and determining another implicational role, whether premissory or conclusory. The haply complication that makes our construction possible is that because we start our semantic interpretation with candidate implications rather than sentences, there are actually two loci on which semantic interpretants to which union-like and intersection-like operations can be applied. We have two basic operations on sets of implications corresponding roughly to intersection and union operations on sets. We call them simjunction and adjunction. Here are the definitions of them. We introduce the sort of square intersection sign and square union sign for them. The simjunction of two roles is just the role of their union. And the adjunction is the role of the set consisting of all the pointwise unions of elements of the one set with elements of the other. Never mind why or what the motivation for that is. This is the way to do it to get the right results. Although both role operations are defined using set theoretic union, the effect at the level of ranges of subjunctive robustness is that of intersection for simjunction, since the range of subjunctive robustness of a set of implications is defined as the intersection of the ranges of subjunctive robustness of its elements. And with these operations on board, we can formulate semantic definitions of sentential logical connectives by showing how to compute their implicational roles of logically complex sentences from the implicational roles of their component sentences. So here it is. Here's the result. Maybe you can imagine how long and how many people it took to figure out that these are the right definitions. What you see on the right is in each case an ordered pair. That's what the angle brackets are showing you. And you can see with the case of negation, it's the ordered pair that has as its premissory role, the conclusory role of the negatum, and as its conclusory role, the premissory role of what's negated. But for the others, you have to look at the ordered pairs. They have two elements, and those ordered pairs are formed from the premissory and conclusory roles of the sentences that are conjoined, disjoined, or in the conditional, but with complicated sets of simjunctions and adjunctions operating on them. It'll perhaps come as a relief to hear that I'm not going to try and motivate these definitions. The philosophically important point is these implication-based semantic definitions for the connectives provide a sound and complete semantics in a very strong sense for the universally LX logic NMMS. These just are the connectives of NMMS. Not only do they determine the same set of purely logical reason relations, but given any non-logical base vocabulary, these semantic rules determine exactly the same reason relations of implication and incompatibility for the logical extension of that vocabulary as those that are determined by the meta-inferential sequent calculus rules that we use to introduce the logic NMMS. These consequences include all the implications and incompatibilities among logically complex sentences that don't hold in virtue of logic alone, but depend on, reflect, and express the idiosyncrasies of the material reason relations of the underlying base vocabulary. That's what I meant when I said that these semantic conditions are sound and provide a sound and complete semantics for NMMS in a very strong sense. The semantic completeness of implication-based semantics for the logic NMMS means that there are two ways to compute the reason relations among the sets of logically complex sentences from the reason relations of a logically atomic base vocabulary. One can do so directly using the connective definitions of NMMS specified in a sequent calculus for metavocabulary. You have those there on your handout. Or one can first compute ranges of subjunctive robustness and implicational roles for sets of implications in the base vocabulary, use those to define premissory and conclusory roles for atomic sentences, combine those roles according to the semantic clauses for NMMS connectives, using role operations of adjunction, simjunction, and inversion, and then determine reason relations from those roles for logically complex sentences by the definition of semantic entailment in terms of roles. The semantic completeness result guarantees that the reason relations that result from these two procedures exactly coincide for every vocabulary. The diagram commutes. This is what I meant by referring to the strength of the correspondence between the functions that compute one set of reason relations from another, specified in our proof theoretic sequent calculus metavocabulary, and the functions on roles that compute one set of reason relations from another, specified in our model theoretic implication space semantic vocabulary. We saw last time that NMMS is universally LX. The expressive completeness of NMMS means that computed in either the sequent calculus way or the implication space semantic way, in terms of conceptual roles, the logically complex sentences completely codify the reason relations of the base vocabulary and of the logically extended vocabulary, in the strong sense that for every set of base sequence, there is a single sequent in the logically extended vocabulary that holds just in case those sequences hold in the base, and vice versa. In this sense, the reason relations of any base vocabulary can be made fully explicit in the form of logically complex sentences of the extended vocabulary. With their reason relations computed in either way, conditionals still express implications, and together with negation, incompatibilities. And just as in the sequent calculus case, NMMS works smoothly to elaborate and explicate even open-structured, non-monotonic, hyper-non-monotonic, and non-transitive reason relations, so too the semantic definitions of the implicational roles of logically complex sentences in terms of adjunctions and simjunctions of the implicational roles of their components elaborate and explicate radically substructural implication space models. Open-structured reason relations, which are not universally monotonic or transitive, or even hyper-non-monotonic consequence relation with implications that cannot even in general be weakened by adding their own consequences to premise sets, all are incorporated into the conceptual roles of sentences in the logically atomic base vocabularies in a way that is faithfully reflected in the conceptual roles of the logically complex sentences that make those consequences explicit, which are derived from them. The conceptual roles conferred even by radically substructural reason relations, still combine with one another logically in just the ways required for expressive completeness, both of the underlying material reason relations and of the reason relations among logically complex sentences that derive from them. Here's the sequent definitions of the NMMS commitments. It's worth comparing these semantic definitions of the roles of logically complex sentences in terms of adjunctions and simjunctions with the roles of their components and the sequent calculus definitions of these connectives. For there's a robust correlation between semantic clauses computing implicational roles from implicational roles and sequent calculus meta-inferential rules, which extends far beyond the soundness and completeness of NMMS. And here it is. It's these three elements. Remember, the roles defined by semantic clauses have two elements, and the first element in those corresponds to the left rule in the sequent calculus. The second corresponds to the right rule. The roles subscripted with a plus stem from sentences that occur on the left in the top sequent, and the roles subscripted with a minus stem from sentences that occur on the right. An adjunction indicates that the adjoined roles stem from sentences in a single top sequent, and a simjunction indicates the simjoined roles stem from sentences that occur in different top sequence. Given that contexts are always shared in all the sequence of any rule application, using this correspondence the semantic clauses above uniquely determine the sequent rules of NMMS and the other way around. And the point is, not just is there a sound and complete implication space semantics for NMMS, there's a general way of getting a sound and complete semantics for any logic you can give a sequent calculus specification of. You just use these three rules to turn the one into the other. Here's an example. If you look at this, let's look at the right rule, so the lower level. We have the sequent calculus formulation on the left and the implication space formulation on the right. The right rule corresponds only to the second element of the ordered pair, that is to A plus adjoined with B minus. So the thing to do, we're only looking at what's above the line because we're giving sufficient conditions for the reason relation below the line to hold. And we don't care about the context. We only care about the sentences that we're going to put in the conditional. Because A occurs on the left, we have A with a plus, B occurs on the right, B shows up with a minus in the semantic form. And because the A and the B are related by a single sequent, they're adjoined. That's just what the rules tell us. Well, we can see how the more complicated conditions work if we look at the top one. For the top one, because we've got three top sequence, all those sequences have to be good for the bottom one to be good. Well, those are sim-joined. And so you see the first element of the ordered pair that's the semantic representation is the sim junction of three different elements. And you can see how the rules determine which those elements are. Only the third sequent, the one on the far right, has both a B and an A in it. Those are the ones we need to have sim joined in order to show that. You get these rules. Okay. The important point is that this correspondence doesn't really have anything to do with NMMS. These principles show how to translate back and forth between essentially any sequent calculus specification of the reason relations of logically complex sentences and an implication space semantic specification of those same reason relations. We can do this for any logic. But remember, this semantics can do this in substructural settings as well. This metalogical correspondence between two vocabularies for specifying reason relations, the sequent calculus one and the implication space one, should be understood as a crucial data point in the ongoing attempt to understand the relative expressive powers of proof theoretic and model theoretic rational vocabularies. I'm not going to go into this, but there's also a straightforward way to construct from any truth maker model an implication space model that validates exactly the same consequence and incompatibility relations and vice versa. So any logic specifiable in truth maker terms is specifiable in implication terms. In particular, the expressive power of the truth maker setting to codify hyper-intentional logical and semantic relations is easily reproducible within implication spaces. Implicational roles are equivalence classes. Okay, what I'm going to say now is an application, another application to show the flexibility and fruitfulness of this implication space way of thinking. Implicational roles are equivalence classes of implications that share a range of subjunctive robustness. And when two implications share their range of subjunctive robustness, and hence play the same implicational roles, that means they're intersubstitutable everywhere, salva consequentiae. You never turn a good implication into a bad one by substituting the one for the other. It can also happen that the range of subjunctive robustness of one implication or set of them is not the same as another, but a proper subset of the range of subjunctive robustness of another. Then the first can be substituted for the second salva consequentiae, but not the other way around. We call these asymmetric relations role inclusions. When we consider role inclusions for propositional contents, we have to consider both the role inclusion of the proposition's premissory role and the role inclusions of its conclusory roles. In a structurally closed vocabulary, if A implies B, then it's also true that substituting A for B as a premise never turns a good implication into a bad one, and substituting B for A as a conclusion never turns a good implication into a bad one. So if we think of A implies B as a good implication, that's the notion of internal consequence. It's the internal to the turnstile. It's the notion of consequence that the turnstile expresses. But we also have the relation. So Pedro is a donkey implies Pedro is a mammal. But that means that there's a role inclusion. Pedro is a donkey can be substituted everywhere for Pedro is a mammal as a premise without ever turning a good implication into a bad one. And Pedro is a mammal can be substituted everywhere for Pedro is a donkey as a conclusion. Now, if you have transitivity as a structural principle, those always go together. But as soon as you go substructural and drop transitivity, they can come apart. And I want to show you one thing that you get when they come apart. And that is that we can understand the trilogics. Now, here, this is going to be a breathless summary if you know about it, if you know about these, and introducing you if you don't. I'm talking about the paracomplete logic K3 and the paraconsistent logic LP. Kripke made K3 famous by applying it to the semantic paradoxes, and Priest's LP is a different solution. In the semantic metavocabulary of three truth-valued logics, these share the same connective definitions. They're the strong Kleene connective definitions. They differ only in how consequence is defined. LP understands the third truth value, a half, as meaning both true and false. And K3 understands the third value as meaning neither true nor false. LP accordingly shows up as the logic of truth value Glutz, which denies the universal validity of the principle of non-contradiction, and K3 as the logic shows up as the logic of truth value gaps, which denies the universal validity of the principle of excluded middle. The fact of interest here is that K3 is the logic of premissory role inclusions, and LP is just the logic of conclusory role inclusions. This is how these logics can be handled in an implication space semantics, but it shows you the inferential version of what you have to do with extra truth values if you're thinking about properties of sentences, true, false, or both, or neither. On the one hand, if you move up to reason relations, it's just a matter of premissory and conclusory role inclusions. We can exploit the connections with truthmaker setting to also show that K3 is the unilateral external logic of verifiers, in the sense that K3 preserves compatibility with the verifiers of the premises jointly to the verifiers of the conclusions separately. And LP is the unilateral logic of falsifiers, in the sense that LP preserves the compatibility potential of the falsifiers of the conclusions jointly to the falsifiers of the premises separately. So the isomorphism between the reason relations specified by the truthmaker semantics and those specified by the implication phase semantics goes beyond the internal bilateral consequence relations all the way down to the external unilateral consequence relations as well. What last time I called the basic discursive bipolarity can show up both in the opposition of truth values, true, false, and the opposition between the premises and conclusions of implications. The fact that what shows up as truth value gaps and gluts in the first sort of metavocabulary shows up as premissory and conclusory role inclusions in the second sort of metavocabulary is another crucial data point in understanding the relations between these frameworks. All right. In conclusion, not just to this lecture, but to the series, I want to say what all this means. In my remarks this time, I've sketched how the outlines of an expressively powerful and metaconceptually enlightening implication space semantics can be formally elaborated from the very spare representation of reason relations in a vocabulary. Just as the classical truth-based tradition envisaged assimilating sentential and other expressions accordingly as they can be intersubstituted salva veritate, that is, without turning any true sentences into ones that are not true, our implication-based approach assimilates implications accordingly as they can be intersubstituted salva consequentiae, that is, without turning any good implications into ones that are not good. Implications and sets of implications are assigned sets of implications as semantic interpretants, implicational roles as equivalence classes of implications with the same range of subjunctive robustness. Only then, following our top-down explanatory methodology, are sentences assigned pairs of implicational roles, so pairs of equivalence classes of implications, as the propositional conceptual contents that are their semantic interpretants. And new, more abstract reason relations can then be defined by operations on implicational roles. And the same union-like and intersection-like operations that produce new implicational roles from old ones then make it possible to define operations corresponding to sentential logical connectives, as well, of course, as lots more, so as to produce a semantics that's sound and complete for the maximally expressive universally LX logic NMMS that I introduced last time. Further, the relations between semantic operations on implicational roles and propositional conceptual contents on the one hand, and features of the sequent calculus rules on the other, turns out to be quite systematic, underwriting a general metalogical correspondence, up to soundness and completeness, of logic specified in the proof-theoretic sequent calculus metavocabulary, and those same logics specified in the model-theoretic implication space metavocabulary. The semantic side of that correspondence can be expressed even more abstractly and perspicuously in the vocabulary of implicational role inclusions. So I began the first lecture by introducing the topic of reason relations of implication and incompatibility. And the announced goal was to use reason relations in the service of a top-down order of explanation, or explication, that would allow the definition in terms of them of the propositional conceptual contents expressed by the declarative sentences that stand in those reason relations. And we've now seen how to fulfill that aspiration, using implications to define ranges of subjunctive robustness of implications, and then implicational roles, and finally propositional conceptual roles. The top-down strategy I've been pursuing was much more thoroughgoing than that, though. Our aim has been to investigate reason relations of implication and incompatibility in their full generality, not restricting our attention to those that exhibit the topologically and explicitationally closed structure of purely logical consequence and inconsistency. That substantial generalization raises a question, though. How do we know we're entitled to call these structurally open, non-monotonic, and non-transitive relations reason relations? Do they still deserve to be called that? The beginning of a response is to be found in the role of reasons relations as specified in the bilateral normative pragmatic metavocabulary whose outline I sketched. But the rest of the answer to that question is to be found in structures at still a higher level. The whole constellation of metavocabularies in terms of which reason relations can be specified as such. In my regimented usage, a vocabulary is a lexicon of sentences together with a set of reason relations defined on them. Those reason relations can be specified in many ways, and any way of doing that is a rational metavocabulary. We considered particular, especially perspicuous instances of four kinds of rational metavocabularies in this sense. The bilateral normative pragmatic metavocabulary that I sketched characterizes the use of declarative sentences in the most minimal recognizable discursive practice. The truth-maker alethic modal semantic metavocabulary characterizes the meaning of declarative sentences in terms of the mereologically structured metaphysical states that make them true or false. The sequent calculus metalogical metavocabulary shows how the reason relations of any base vocabulary can be conservatively extended to include logically complex sentences formed from the sentences of the lexicon of that base vocabulary, and how those logical sentences make it possible to explicitly express reason relations. And the implication space semantic metavocabulary, as the language of roles, shows how to construct, control, and manipulate propositional conceptual contents on the basis of reason relations among the sentences that express those contents. My overall argument is that reason relations are whatever can be specified, elaborated, and discussed by metavocabularies of all of these four kinds. Reason relations are the common topic quadrangulated by the metaconceptual perspectives provided by all these kinds of rational metavocabularies. We carefully crafted our versions of each kind of metavocabulary to ensure that its expressive reach extended to radically substructural or open structured reason relations in the base vocabularies to which it is applied. So the top-down methodology that seeks to understand propositional contents in terms of reason relations extends to a further upper layer, aiming to understand those reason relations in terms of the rational metavocabularies that we use to talk about them. Compelling as I hope this response is, we can ask further, in exactly what sense do these very different kinds of metavocabulary afford perspectives on a common topic, namely reason relations? Responsibly adapting the visual spatial metaphor of perspectives to the case of different conceptual specifications of one object requires at least a characterization of the space that the different perspectives occupy in, and a correlation between their positions in that space and how things look from that position. Our four metavocabularies are of two different kinds. Both the bilateral pragmatic metavocabulary and the truth-maker semantic metavocabulary offer substantive explanations of reason relations. In the bilateral normative sense, a set of sentences gamma implies a set of sentences delta, just in case commitment to accept all of gamma precludes entitlement to reject all of delta. That's what implication means, according to that pragmatic metavocabulary. In the truth-maker alethic sense, gamma implies delta, just in case every mereological fusion of any truth-maker of all of gamma with any falsity maker of all of delta is an impossible state. That's what implication means, according to that metavocabulary. Those are very different explanations. Each appeals to concepts native to its own setting, which go far beyond what's made available in the sphere structure of a vocabulary. Concepts such as acceptance, rejection, commitment, entitlement, metaphysically possible or impossible states, mereological sums, and so on. We can say that the bilateral pragmatic and truth-maker semantic rational metavocabularies are extrinsic explanatory rational metavocabularies. They appeal to features extrinsic to the reason relations of the vocabularies they address, and they do so in order to offer substantive explanations of implication and incompatibility. Of course, we showed a strong isomorphism between these two. By contrast, the logical and implications-based metavocabularies are intrinsic explicative rational metavocabularies. They're intrinsic in that they appeal to no conceptual resources beyond the minimal formal representation of reason relations as sets of pairs of sentences drawn from a lexicon, that is, resources afforded by the abstract concept of a vocabulary. And their aim is not to explain what it is for reason relations to obtain between sets of sentences. but rather just to provide the metaconceptual resource to say what those reason relations are and make explicit the conceptual roles that sentences play in those reason relations. Just as the top-down methodology requires understanding the propositional contents expressed by sentences in terms of their role with respect to reason relations among those sentences, and reason relations in terms of the rational metavocabularies that explain or articulate them, so too that methodology invites us to understand those metavocabularies in terms of their relations to each other. I've emphasized two of these and mentioned a third in passing. First is the isomorphism at the level of reason relations that O'Flobel crafted between the bilateral normative pragmatic extrinsic explanatory metavocabulary and the truth-maker alethic modal semantic intrinsic explanatory metavocabulary. The intrinsic explicative metavocabulary should both be thought of as making explicit reason relations in the abstract sense that that isomorphism shows them to be common to the otherwise disparate extrinsic explanatory metaconceptual frameworks. Second is the strict correspondence I talked about this time between structural features of the sequent calculus metavocabulary for computing the reason relations of logically complex sentences from the reason relations of base vocabularies on the one hand, and the construction of conceptual roles from conceptual roles by the operations of adjunction and simjunction on the other hand. These two tight structural covariances at the level of reason relations, which characterize the two orthogonal axes of extrinsic explanatory and intrinsic explicative rational metavocabularies, are then cross-connected by a third relation. For, as I reported, for each truth-maker model, we can construct an implication space model that articulates the same reason relations, and for each implication space model, we can construct a truth-maker model that endorses the same reason relations. These relations among the four cardinal varieties of rational metavocabulary functionally characterize the space of positions from which each metavocabulary affords a perspective on reason relations, and so propositional conceptual contents. Here's one final perspective on this intricately structured constellation of rational metavocabularies. Discursive awareness, consciousness in the sense of sapience, rather than the mere sentient consciousness manifested in being awake rather than asleep, consists in being able to respond to things by making propositionally contentful claims about them, being able to commit oneself to accept or reject claimable contents, and keep track of the way entitlements to such commitments interact and depend on claims offered as reasons for or against others. The bilateral normative pragmatic metavocabulary I sketched in my first lecture accordingly articulates a kind of theoretical pragmatic self-consciousness, for it provides the expressive power that enables us theorists to say what it is that practitioners must do in order thereby to count as making conceptually contentful propositional assertions and denials, and so to be conscious in the sense of sapient, namely able to claim that things are thus and so. The truth-maker rational metavocabulary enables a corresponding sort of representational semantic self-consciousness, for it provides the expressive resources to make explicit crucial relations between claimable conceptual contents and the worldly states that make them true or false. Base vocabularies that have been extended and expressively enriched by the introduction of logical vocabulary are the organs of a distinctive kind of pure rational self-consciousness. For as we've seen, sentential logical vocabulary embodies the expressive power to make explicit reason relations of implication and incompatibility, both non-logical and logical. Intrinsic implication space rational metavocabularies are the organs of a distinctive kind of pure semantic theoretical self-consciousness. For they are the native language for specifying the conceptual roles sentences play in virtue of standing to each other in reason relations. So, the isomorphisms and correspondences among the four different kinds of rational metavocabulary I've been rehearsing as the very topmost level of the top-down order of explication sketched here can be understood as articulating the internal structure of rational self-consciousness as such. I'm happy to close these lectures bathing in the Hegelian resonances of that thought. Thank you very much.
Thank you. There are time for questions, and those of you who attend remotely, please write in the chat if you'd like to ask something. Anyone in the auditorium with a question? Yeah.
Thank you, Professor Brandom, for these 3 lectures. My question is more of a leftover from yesterday after I've had time to digest it a little bit. So yesterday you emphasized your logical expressivism, and correct me if I'm wrong. Your point was that logic does not constitute what is a good reason, but merely helps us make explicit material implications or material inferences that are already in some sense good, right? And this of course is very, is kind of like the polar opposite of someone like Frege, who in his like Der Gedanke talks about logic as being about the laws of truth, right? Or when he conceptualizes logic as being this kind of even Leibnizian characteristica universalis, where you translate anything non-logical into the logical system and work it out. But then again, Frege, when he developed his logic, his conception of logic was very much motivated by his desire to refute Kant's claim that arithmetic is synthetic a priori, right? So he wanted to formalize the notion of proof to show that mathematics is just pure logic. So, but then I wonder, how would a logical expressivist understand mathematics and the role that logic plays in mathematics, right? Because I think that mathematicians today, they're still kind of influenced a bit by of course, no one's a logicist in the Fregean sense anymore, but they still have this idea that, okay, you start with axioms, and then the point of a mathematical proof is that logic supplies these valid rules of inferences that allows us to get true mathematical theorems, right? But if you're an expressivist, how do you account for the role of logic in mathematical proofs? Or just like more broadly, how does mathematics fit into your picture? Because you haven't talked about that much.
Okay, thank you. Very good. I mean, Frege goes both ways. In the Begriffsschrift, he starts off saying the Begriffsschrift is a concept script. And he says, I want to express conceptual contents, and I want to say that 2 things have the same conceptual content if substituting one for another never turns a good inference into a bad one. That's the notion of conceptual content. He says he wants his logic to express. So, I think the expressivist way of thinking about logic is Frege's way of thinking about logic. Anyway, one of his ways. He also had others. His logicism was self-avowedly aimed not at putting mathematics on a more secure, more epistemically secure foundation, but rather making explicit the structure of mathematical concepts. So in the 3rd part of the Begriffsschrift, seldom read, he reconstructs the concept of continuity there in a way that lets you prove one of the theorems, the constant value theorem, that was one of the triumphs of mid-19th century mathematics, as a purely logical conclusion. What he's interested is not saying, and therefore now we really know that this is a good proof. It's no, now we know that we have adequately expressed the conceptual content of the concept continuity, because our concept logically stands in the right reason relations. I think classical logic is the right logic to express topologically closed reason relations, which mathematical ones are. It's absolutely crucial to mathematical reasoning that it be transitive, that the conclusions of one argument are instantly available as premises for other arguments, and you don't need to worry about stringing these things together forever. That's the triumph of mathematics. In the case of mathematics, we can say, if we like, that good mathematical reasons are good logical reasons. That isn't true at the level of sort of high level mathematical reasoning, but we can show a logical framework for any mathematical argumentation in proofs. The question is, for the logical expressivists, what about the rest of reasons? The ones that aren't mathematical, the ones that aren't always monotonic, aren't always transitive, as probabilistic reasoning is not always monotonic. Are we to look for logic underneath all the good implications and all the incompatibilities there as well? And here, the difference between the different strands in Frege really makes a difference. We can use logic to articulate those and make explicit those implications and incompatibilities. Well, at least if we use the right logic, and MMS can do it, but they won't come out as logically good inferences according to NMMS or anything else. The inference from Pittsburgh is to the west of New York, so New York is to the east of Pittsburgh. That's not a logically good inference. It's not. It's only good in virtue of the non-logical content of the concepts east and west. But we can say, in logical terms, that that is a good implication.
Thank you for the talk. My question is about how your reasons relation is concerned mainly with reasons for belief. Do you think that you accept or reject P? Do you think this can also be applied to reasons for action?
The short answer is no. I think doxastic reasoning and practical reasoning are quite different. Now, maybe implicit in your question is, does this teach us anything about the relation between them? Can we say anything about why these are both reasoning? Well, yes. I mean, I think of practical reasoning as reasoning from commitments to commitments that is entitlement preserving in the way that doxastic implication is. But in addition to doxastic commitments, there are practical commitments, the commitment to do something. And those can at least be, what's distinctive of practical reasoning is that there's some of those in the conclusions. And in the fullness of time, what one would like is to extend, to subsume the apparatus that I've sketched in these 3 lectures as part of an account of a reasoning general that included pragmatic reasoning. Indeed, my collaborator and co-author, Ulf Lobel, that's really what he cares about. He considers all the rest of this elementary and propedeutic to concerned with what really matters, which is practical reasoning. But he says we ought to get this simpler theoretical reasoning. Well, let's get straight about that first, and then we can move to the really important case. So another lifetime's work in view there.
Further questions? I have one of my own. It's a sort of an old problem for the kind of count you describe here, but I'd be curious to hear about your views on sort of how to account for interpersonal sameness of meaning, in particular between different languages, on something like implication-based semantics.
Okay, so there's always a worry that individuating concepts by their inferential roles cuts too fine. Quine talks about this already back in 2 Dogmas. what follows from a claim that I make, according to me, depends on what my collateral commitments are. What other commitments do I have that can serve as collateral premises in extracting those consequences? I could, make a claim that the sun is shining, and if you have very different views about the sun, maybe you're a Zoroastrian, you think it's the beatitude of Zoroaster, you're going to draw different conclusions from it than I do. Seems like we mean different things. There, I want to say the pragmatics that I gave a sketch of is a normative pragmatics, and it's going to see our differences in collateral commitments as taking place within a shared set of binding norms. When you and I both claim the coin is copper, it's not really up to you or me what follows from that in the sense of what we've committed ourselves to by being copper. The metallurgists can tell us what else we've committed ourselves to, what's implied by it and what's incompatible with it. When I play the counter in the game, copper, when I make that move, it's up to me whether I make that move. Is it copper or is it aluminum? But it's not up to me which move I've made. I've bound myself by the norms of copper. I've committed myself by whatever you publicly commit yourself to in the way of implicational consequences by calling it copper. For instance, even if I don't know it, I've committed myself to its melting at 1084 degrees C. That's part of the norm that binds me. So within a linguistic community, I think there's a common set of norms. This is a Kantian point. Concepts are not to be understood in terms of what it takes for me to grasp it. The important thing about concepts is their grasp on us, the hold that the norm has when I play that public counter in the game, copper. I've bound myself by this norm. The implication-based semantics is supposed to be just what we want to understand the relation between the Swedish speaker and the English speaker. They can be expressing exactly the same conceptual contents. It's a matter of whether the ranges of subjunctive robustness of their terms are the same. The implication-based semantics precisely provides a point of view at which we can characterize the norms that articulate the concepts in one community with the norms that articulate the concepts in another community. That's part of what this apparatus is supposed to do.
Okay, thank you. We have a remote question as well. Virginia.
Hello, thank you. Okay, so I had a question concerning the beginning of the lecture. So when you talked about the fact that the first step in a theory that investigates reasons is the model element that I think is the point of your logical theory of NMNS. I mean, I don't know what the letters are, but that theory is supposed to explain the model element in reasons as such, right?
It's supposed to articulate it. I mean, as I understand it, these intrinsic explicative metavocabularies, the logical and the implication space, they're not trying to explain anything. Explanation is for the other kinds of metavocabulary, semantic explanation, pragmatic explanation. These are explicative. The point of these metavocabularies is to let you say something, to extend your expressive capacity, in particular to be able to specify any reason relations whatsoever. In the logical metavocabulary gives you resources to add to your language, so you can do it in your language. The implication space does it from outside. You don't need to be, it doesn't have to be an extension of the base language. It's just another meta language.
Okay, so so if I have an example, like Rome is south of Milan, so this is for you, it's a material inference, right? And this material inference is first articulated by this model element that you understand in this logical way.
Yes, we're to think about the range of subjunctive robustness of an implication. Suppose I say, if I strike this dry, well-made match, it will light.
Mm.
Part of understanding that is understanding the circumstances under which that implication still would hold, and the circumstances under which it doesn't. So, if I strike the dry, well-made match, it will light. If I strike the dry, well-made match, but there's a very strong magnetic field, then it won't light. But if I strike the match and there's a powerful magnetic field, but I'm in a Faraday cage, then it will light. Having those sorts, that's the modal dimension of some implication. It's not enough just to know that the implication from it's being a dry, well-made match to it will light is a good one. You have to have some sense of what changes would make a difference to that, would turn it from a good inference into a bad one, in order to count as understanding it.
Okay, so thank you for these clarifications. My real question then, I just wanted to make sure that basically your theory aims at understanding the extensional component of inferences. So what you talk about in terms of this intentional element that you described throughout the lectures. But if that is the case, I was wondering, what do you make of, those, for instance, those periods of time where in the scientific paradigm, the intentional role of physical entities is not yet determined, and therefore there are multiple interpretations. Because if it is the intentional element that determines the extensional physical entity, and the intentional element is not yet determined, but there are arguments between physicists, how do we understand that in your theory?
Okay. I mean, that's a very good question, and I don't have a very good answer for it, uh, because everything I've talked about has been at the level of sentences, and not the subsentential level at which we could talk about properties, relations, and objects. So, I don't have enough. The apparatus doesn't cut finely enough, as I've described it, to fill in everything in the Feinean truthmaker framework that would let us say how this conceptual content gets connected to this sort of metaphysical feature of the universe. There isn't a theory of reference in here. As far as I am giving us words to talk about it, the representation of the world by the mind or language, by our concepts, happens, it is intelligible at the level of reason relations. How that representational relation at the level of reason relations relates to objects, properties, and relations, that's a question for another day. I mean, it's not that we have nothing to say about it, but nothing that I've said in these three lectures helps with that problem. It just brings us to the point where we can ask that question.
Okay, thank you.
Any final questions? No. So since we're running out of questions, I'm going to move into view here. And on behalf of the department, thank you for these wonderful and challenging lectures. And usually when the presenter for these lectures is present, physically present, we surprise them with the Pufendorf medal and a diploma as a token of our appreciation. I will have to be content with just displaying them on Zoom for you. here. And then later surprise you when they arrive in the mail. Thank you so much for these lectures and for challenging us and displaying this novel perspective on how reasons, the nature of reasons. Thank you.
Well, thank you. It's been a pleasure. And you can probably tell I like to tell these stories. And I know they're not easy to process. And I admire your being willing to sit through all of it. And I hope you got something to take away from it that was worth it. But it's been a pleasure for me. If you do care more about these things, there's even more of it in the book. So you know where to go. Thank you very much.
Thank you.